Good morning, friends. Let's start with second unit, mechanical systems. Up to this, we have discussed about the steam distribution in the boiler, then energy conservation in compressed air systems, then energy conservation opportunities in refrigeration and air system, air conditioning system, then energy conservation opportunities in a fan. Fan and blowers. In last lecture we discussed fan and blowers. 1 minute. So next point is energy conservation. In fans and blowers. Here, fans and blowers provide air for ventilation and industrial purpose, right? So fans generate a pressure to move air against resistance caused by ducts, dampers, or other components in a fan system. The fan rotor receives energy from a rotating shaft and transmits it to air. So difference between fans and blowers and compressor. Here, fan, blower and compressor are differentiated by the method used to move the air and by the system pressure they must operate against, right? What is the use of compressor? To compress the air. What is the fan? What is the use of fan? To flow air from towards the room, right? And blower is remove air, right? These are the use of that fan, blower and compressor. As American Society of Mechanical Engineering, the specific ratio, the ratio of discharge pressure over the suction pressure is used to define the fan, blower and compressor. So difference between fan, blower and compressor in the with respect to specific ratio. The specific ratio for the fan is up to 1.11 and blower up 1.11 to 1.20 and compressor more than 1.20. This is the specific ratio, right? Fan types. Then fan types. Fan and blowers. Blower selection depends on the volume, flow rate, pressure, type of material handled, space limitations and efficiency. Fan efficiency differ from design to design and also by types. Typical ranges of fan efficiencies are given in our table. So first of all, fans fall into two general categories: centrifugal flow and axial flow. In general, centrifugal flow air flow changes direction twice, once then entering and second then leaving. Forward curve, backward curve or inclined radial vanes are used. In axial flow, air enters and leaves the fan with no changes in the direction, that is propeller, tube, tube axial, etc. See here, we have to discuss energy scenario in the fan. Energy energy conservation opportunities in a fan. See here, minimizing demand on the fan. First point, minimizing excess air level in the combustion system to reduce FD fan and ID fan load. So minimizing air in leaks in hot flue gas path to reduce ID fan load, especially in case of kilns, boiler plants, furnace, etc. Cold air in leaks increase ID fan load tremendously. Due to density increases of flue gases and in fact choke up the capacity of fan, resulting as bottleneck boiler for furnace or boiler. In leaks, out leaks in air conditioning system also have to measure impact on energy efficiency and fan power consumption and need to be minimized. The findings of performance assessment trials will automatically indicate potential areas for improvement, which could be one or more of the given. First, change of impeller by high efficiency impeller along with the cone, change of assembly as a whole by higher efficiency and impeller derating, right? Then the change of metallic glass reinforced plastic impeller by the more energy efficient hollow FRP impeller, fan speed reduction by pulley diameter modification of for derating, then option of 2-speed motors or variable speed drives for variable duty condition, option of energy efficient fan belts or coke draw edge V belts in place of conventional V belt systems for reducing transmission losses. Adapting in inlet guide vanes in place of discharge damper control and minimizing system resistance and pressure drops by the improvements in the duct system, right? Next is solar water heating, that is SWHS. By this we can conserve more energy in daily life. We need hot water, so we use electricity. So instead of electricity we have to use solar water heating system. The solar water system consists of two main parts. One is solar collector and other is storage tank. The collector used in this is flat plate type. The solar radiation directly falls on the collector surface and the solar energy is converted into thermal energy. Water is circulated in the tube and gets heated by solar energy. Heated water is then stored in the storage tank for use in the process. However, the existing conventional system is sometimes also maintained to provide the thermal heat required during inclement weather condition. Passive solar water heaters. See here, next point is passive solar water heaters. Passive solar water heating system works on a thermosiphon principle. Such systems are economical and reliable choice. These systems work on the natural convection of water. As water is in the solar collectors heats, it becomes lighter and rises naturally into the storage tank above. Meanwhile, the cooler water flows down the pipes to the bottom of the collector, enhancing circulation. See here, while as a question will ask, you have to draw the diagram for this. I will draw a simple diagram. Here, this is the simple diagram. Solar collector are the key components of this SWHS, that is solar water heating system. Solar collectors gather the sun's energy, transform it radiation into heat, and then transfer that heat to water. There are several types of solar collector, that is flat plate collector, evacuated tube collector, and higher collector storage system. However, flat plate collectors are generally used. So this is a flat plate collector. Flat plate collectors are the most common solar collector for SWHS, and a typical flat plate collector is an insulated metal box with a glass or a plastic cover and a dark color absorber plate. The collectors heat liquid or air at temperature less than 80 degrees Celsius. Liquid flat plate collectors heat liquid as it flows through tubes in or adjacent to the absorber plate. The simplest liquid system use portable water, which is heated as passes directly through the collector and then flows. Next is what are the points covered in the SWHS, that is which helps the energy conservation when we use other than solar collector for heat the water. Then wood consumption will be there, environmental pollution, safety work, maintenance, etc. Though the availability of water intermittent and requirement of hot water is partially met, the other benefits of solar hot water systems, such as relatively nil operational in maintenance cost, clean and free from the energy, and other economic benefits such as available of capital subsidy and accelerated depreciation, it is makes the attractive proposition for the cluster units to install a solar hot water system. Next, economic benefits. What are the general we have the economical benefits? First is fuel saving, electricity saving, improvement in product quality, increase in production, reduction in raw material consumption, then money benefits. Fuel saving, the wood saving due to installation SWHS is typical unit having 50 LPD hot water generation capacities in estimated 19.6 ton per annum. Electricity project implementation will not save electricity consumption. Improvement in the product quality. Product quality achieved would be same as the present quality. It does not have any impact on it. Increase in production. The proposed equipment does not contribute to increase in production. Reduction in raw material consumption. Raw material consumption is same even after the implementation. Then money benefits we have discussed. These are the points that we have covered in this lecture. Okay, about the SWHS. Then next is very important point, that is biofuel. Basics of biofuel. See here, unlike the other renewable energy sources, biomass can be converted directly into liquid fuels called biofuels to help meet transportation fuel needs. The two most common types of biofuels used today are ethanol and biodiesel, both of which represent the first generation of the biofuel technology. So, the bioenergy technologies is collaborating with industry to develop next generation biofuels made from non-food resources. Over the past decade, biotechnology focus on the cellulosic ethanol, investing in technology advances throughout the supply chain. These activities successfully validated critical technologies for cellulosic ethanol production. See here, then about ethanol. Ethanol is a renewable fuel that can be made from various plant material collectively known as biomass. Ethanol is an alcohol used as a blending agent with gasoline to increase octane and cut down carbon monoxide and other smoke causing emission. The most common blend of ethanol is ethane. Some vehicles called flexible fuel vehicles are designed to run on E85, that is gasoline. So most ethanol is made from plant starches and sugar, but scientists are continuing to develop technology that would allow for the use of cellulose and hemicellulose, the non-edible fibrous material that continues the bulk of the plant matter. In fact, several commercial scale cellulose ethanol are operational in the United States. The common method of converting biomass into ethanol is called fermentation. During fermentation, microorganisms metabolize plant sugars and product of ethanol. Next point is biodiesel. So biodiesel is a liquid fuel produced from renewable sources. Such new and use vegetable oils and animal fats, and is cleaner burning replacement for petroleum based diesel fuel. Biodiesel is non-toxic and biodegradable and is produced by combining alcohol with vegetable oil, animal fat, or recycled cooking greases. So, like petroleum derived diesel, biodiesel is used to fuel compression ignition engines. Biodiesel can be blended with a petroleum diesel in any percentage, including B100, that is pure biodiesel. B100 is called as pure biodiesel. And the most common blend, B20. There is a blend containing 20% biodiesel and 80% petroleum diesel. This is all about the basics of biofuels. There are two types of biofuels, one is ethanol, second one is biodiesel. So in next lecture we discuss international recent advances in biodiesel. So in next lecture we'll discuss that point. If you have any doubt, please ask me. This chapter is also we will finish the chapter after in a second in next week. So thank you very much. Thank you.